Okay, welcome everybody. Today we're going to talk about lesson number 16. So this is still section 2.3. It still has to do with synthetic division, but we're going to focus on something called the remainder theorem and the factor theorem. Again, theorems that you probably have heard of before, maybe just not for a while, so never hurts to review them. So the remainder theorem, if a polynomial f of x is divided by x minus k, then the remainder, r, is equal to f of k, which basically means if you were to switch the sign of whatever's inside of your parentheses, just like we do when we perform synthetic division, if you go ahead and plug it into the equation for all the x's, you're going to get an answer that is equivalent to the remainder. What the factor theorem says is that a polynomial has a factor if and only if the remainder is equal to 0. So that should kind of make sense because in order for something to be a factor, it has to divide in evenly, which of course by definition means that the remainder is equal to 0. So if you kind of want to see these into practice, what a question would look like, use the remainder theorem to evaluate the polynomial at x equals negative 2. So first and foremost, let me just point out here that this is x equals negative 2. From this point forward, whenever you see an x equals, that means that you are going to use that value. You are not going to switch the sign. You only switch the sign when it's given to you as a factor. You always want to wind up putting in the value that is the 0. So when it's equal to, you do not switch it. So what the remainder theorem says is that if you go ahead and calculate f of negative 2, which means everywhere there's an x, you're going to put a negative 2. If you go ahead and do that calculation, the remainder theorem says that is what the answer that you get would be the remainder if you were to divide by x plus 2. So f of negative 2 would be 4 times negative 2 cubed would be negative 8. Plus 10 times negative 2 squared would be 4. Negative 3 times negative 2 would be plus 6. And then minus 8. So negative 32 plus 40 plus 6 minus 8. Negative 32 plus 40 is 8, plus 6 is 14, minus 8 is 6. So f of negative 2 is equal to 6. And according to the remainder theorem, the fact that f of 2 equals 6 means that if I were to perform synthetic division of x plus 2, the remainder would in fact be 6. So a couple of things that this tells us. What this tells us is that negative 2 comma 6 is a point on the graph of f of x. What that also tells us is that x plus 2 is not a factor of this polynomial. We know that this is not a factor because of the fact that it's 6 and not 0. Any remainder other than 0 means that it is not a factor. So again, using the remainder theorem simply means plug in whatever the x value is, and whatever you get out would be the remainder if you actually did the synthetic division. To be honest, it would probably take the same amount of time to go ahead and do the synthetic division, but the remainder theorem is meant to be a bit of a shortcut, or if nothing else, it certainly is just a relationship. So something that's very important to know is that synthetic division can be done multiple times in a row on the same polynomial. And of course, every time you do a round of synthetic division, it reduces the degree by 1 every time. Your goal should always be to take whatever polynomial you start with and get it down to degree 2, because degree 2 means it's a quadratic, and all quadratics can be solved either by factoring or the quadratic formula. If you get down to a cubic, some cubics can be solved, but if you get down to a quadratic, every single one can be solved, which is why it's a good idea to try to always get it down to degree 2. So it's possible that last year when you did synthetic division, you did not do that in a row like we're about to. So if this part is new for you, then make sure that you be sure to utilize it going forward. So show that x minus 3 and x plus 2 are factors of the given polynomial. Then factor completely and solve. So first of all, the fact that I say show that they are factors means they are. So you know that they should divide in evenly, which means you should get a remainder of 0. If you don't get a remainder of 0, then you know that you're doing it wrong. Second thing that you should notice is that they are giving you these as factors, which means when you go to do synthetic division, you have to reverse the signs, which means the x values in question are actually 3 and negative 2. When you go to start by copying your coefficients, using any placeholders as needed, which in this case we don't need any. So 1, -4, -7, 22, and 24. It does not matter which of these roots you start with. I'm just going to go in the order that they gave me, and I'm going to start by plugging in 3. Again, fingers crossed, I should get the remainder of 0. That's the whole point of being a factor. So bring down the 1, multiply to the box, add the column, multiply to the box, all the way down the line. Looks like we're off to a good start. We went ahead and got that first remainder of 0. Think about what it is you did here. These coefficients here represent the quartic function. These coefficients here now represent a cubic function. Again, a cubic maybe is factorable. The fact that it's 1, -1 and -10, -8 is kind of a clue that it's not, because the only way that I'd be able to solve it is with grouping, and I can clearly see that I'm not going to get that repeat factor. But here's where the idea of doing synthetic division multiple times in a row comes in. Now that I know that 3 works, whatever polynomial is left has to be divisible by whatever root I haven't used yet. So right underneath, I'm going to go ahead and put -2 in the box. When you draw your line, skip the 0, since the remainder is 0, that's no longer part of the problem. And you're now going to use 1, -1, -10, -8 as your coefficients. That is the cubic function. So perform synthetic division again by bringing down the 1, -2, -3, 6, -4, 8, and 0. So look at that, exactly as I was hoping for. I went ahead and got that second remainder of 0. So I started off with a quartic. Then these coefficients represent a cubic, which means that these coefficients now represent a quadratic, which means this is x squared minus 3x minus 4. So this is what I was talking about on the previous slide when I said you should try to do as many synthetic division rounds as you need to get down to a quadratic, because every quadratic is easily solvable, again, either by factoring or the quadratic formula. So going back to what the problem said, show that they are factors, check, check. Now I want to factor completely and solve. So I'm going to go ahead and do that on the next slide. So by factoring completely, again, remember, the first factors were given to me, x minus 3 and x plus 2. And I now have x squared minus 3x minus 4. Luckily for me, that does factor. So x minus 3, x plus 2, x and x. Factors of -4 that add up to be -3, that's going to be x minus 4 and x plus 1. So when the problem says factor completely, this is what they're looking for. Factor completely means if it's a quartic, you need 4 factors. If it's a cubic, you need 3 factors. And again, typically you're going to factor depending on what I ask for. I can say factor over the real numbers or factor over the integers, or I can kind of tell you how far to go. For now, factor completely means just go as far as you can. So there are my 4 factors. And then when they say solve, that means you're going to go ahead and set it equal to 0. Of course, a quartic should have 4 solutions, and they turn out to be 3, -2, 4, and -1. So again, very important that you not only answer the question, but that you answer the question that is being asked. Factor completely means down to here. Solve means down to here. And a lot of the problems on the homework obviously ask you to do both. Slightly different scenario here. Show that x equals 2/3 is a solution of this polynomial, then factor completely and solve. So something a little different is we have some fraction action here, which always just makes things slightly more difficult, but not terrible. The fact that this is a cubic means that if I have just one solution, I'm going to get down to a quadratic, which means I'm only going to have to do 1 round. So again, starting off with my coefficients, no need for any placeholders, but always be on the lookout. The fact that x equals 2/3 is a solution means that this should divide in evenly. Again, if it doesn't, you're in trouble. So even though there's a fraction, you just kind of have to be extra careful here. So if you're extra careful here, you're going to go ahead and bring down the 3. 3 times 2/3 is a 2. Adds to be -12. 2/3 times negative 12 is negative 24/3, also known as negative 8. Add the column to get negative 15. 2/3 times negative 15 is negative 30 over 3, which is negative 10. And look at that. I go ahead and get that 0. Here's where you just have to be a little bit careful again when it comes to something with a fraction. So this is technically 3x squared minus 12x minus 15. This 2/3, if you were to write that as a factor right now, it would actually be x minus 2/3. But if you look at the way that that's written, we don't really ever leave it like that. So whenever there's a fraction involved, whatever you're left with as your quotient, you're going to wind up having a common factor, which in this case is 3. If you pull that 3 out, you're then going to be able to join it up with whatever you originally had here, just to kind of clean it up and make it all integers. So again, this common factor of 3, I'm going to multiply it by x minus 2/3. That's going to give me 3x minus 2. So again, going back for a second here, I just wanted to take this 3 that was the common factor. I wanted to get rid of this fraction by making it 3x minus 2. Then to factor this, and it won't always factor, but it does for now, factors of negative 5 that add up to be negative 4. That's going to be x minus 5 and x plus 1. And just so you know, it doesn't matter which order you put them in. So if it said factor completely, it's that. If it now says solve, you're going to go ahead and set it equal to 0. And your answers would, of course, be the 2/3 that you were given, positive 5 and negative 1. So again, factor completely versus solve. Make sure that you can do both and make sure you only do each one when I ask for it. A couple of other things that belong in this section, just kind of a random problem here, find that mystery polynomial. So the leading coefficient of a cubic polynomial, p of x, is 2. The coefficient of the linear term is negative 5. If p of 0 equals 7 and p of 2 equals 21, find p of 3. So whenever you're kind of given a problem like this, you always have two options. You can either use synthetic division or long division, although synthetic division is typically always easier, or you can kind of just use the idea of plugging in values. Remember, the whole point of p of 2 equals 21 means if you put a 2 into the equation for x, you should get back 21. What it means for synthetic division is if you put a 2 in the box, you should get a remainder of 21. So you kind of just want to keep in mind what it is you're playing with here. So p of x is a cubic polynomial that has a leading coefficient of 2 and a linear coefficient of negative 5. So to start off, I know that my polynomial is going to be ax cubed plus bx squared plus cx plus d. Then more specifically, they tell me that this is a 2x cubed minus 5x plus d. So that's what I know so far. Now I need to try to use the other pieces of information. So the fact that p of 0 is equal to 7 means if I put a 0 in for all the x's, I'm going to get a 7, which actually means that it's the y-intercept, which means that is the value of d. I'll check if I left myself an extra screen. Okay, I didn't, so I got to write a little smaller. So then from here, the last piece of information that I have here is the fact that p of 2 is equal to 21. So that means that given this polynomial, if I plug a 2 in for all the x's, I'm going to get a 21 out, which means I'm going to be able to solve for the only variable left, which is b. And then once I solve for b, I'll have the whole polynomial, and then I can find whatever it is I want. So 21 is equal to 2 times 2 cubed is 8, plus 2 squared is 4b, 5 times 2 is 10, plus 7. So 21 equals 16 minus 10 plus 7 plus 4b. So I'm going to go ahead and move all my constants to the left-hand side there. So 21 minus 16 is 5, plus 10 is 15, minus 7 is 8. So I'm going to wind up getting that 8 is equal to 4b, which means that b is equal to 2. So that means that my polynomial function, and again, sorry, I kind of ran out of room here, is going to be equal to 2x cubed plus 2x squared minus 5x plus 7. That is the polynomial that I was looking for in order to find p of 3. So to find p of 3, I again have two options. I can take this equation, and everywhere there's an x, I can put a 3, or I can copy those coefficients, put a 3 in the box, do synthetic division, and whatever the remainder is, that's going to be my answer. Either way, you should get an answer of 64. It is possible that there are other ways to do this, again, using synthetic division or, guess and check, I suppose, is an option, although I always think that's the worst option, especially since, the majority of our tests are online and there's a time consideration. So the more methodical you can be, I just think the better off you are. And of course, the more partial credit that you can be awarded. The last couple things I want to talk about here is the idea that any imaginary or irrational roots must come in pairs, and these are called conjugates. So if I was to tell you that the square root of a was a solution to a problem, that would automatically mean that the negative square root of a was a solution. If I was to tell you that bi, that's imaginary number, was a solution to a polynomial, automatically negative bi. A plus the square root of b, a minus the square root of b, a plus bi, and a minus bi. So everything about these problems here says that they have to come in pairs. And again, that's what it means to be conjugates. So then there's kind of a special little rule here, a little bit of a shortcut. It's possible you've never seen this before. So if it's the first time, definitely make sure that you're writing it down. So given any pair of conjugate roots, again, the conjugates were all on the previous slide, the equation of the quadratic that yields them always takes the following form. And again, just to explain that first in layman's terms, if you're telling me that the square root of 5, for example, is a solution, that means that negative square root of 5 has to be a solution. What is the quadratic that gives me those two solutions? If I say that 4 plus 3i is a solution, automatically 4 minus 3i has to be a solution. And again, you're trying to find the quadratic that has these two things as an answer. So here is a quick, easy formula of how you do that. In order to find that quadratic, it's always going to be x squared minus the sum of those two roots times x plus the product of those two roots, and that's always going to be equal to 0. And then I kind of just shortened it a little bit in the last line there. So again, given any pair of roots, conjugates, imaginary or irrational, sometimes both, you're always going to find the quadratic that gives those as the answer by doing x squared minus the sum of those roots times x plus whatever the product of those roots is equal to 0. So I'll give you a second to write that down. And then let's go ahead and look at what a question like that would look like. So suppose I tell you that 2 minus radical 5 is a root of this cubic. Factor the polynomial completely and find all the remaining roots. So the fact that x equals 2 minus radical 5 is a solution. I automatically should write 2 plus radical 5. Those are a pair of conjugates. 100%, if I know that one of them is a solution, automatically the other has to be a solution. In order to use that formula from the previous slide, x squared minus the sum of the roots times x plus the product, I have to literally find the sum and the product of these two roots. So to find the sum, you're going to add 2 minus radical 5 to 2 plus radical 5. Here's the thing about conjugates. The backs will always cancel. So in this case, I literally just get 4. Then you're going to do the product of 4 minus radical 5 times 2 plus radical 5. When you're doing the product of conjugates, remember you only need first and last. So you're doing 2 minus radical 5 times 2 plus radical 5. You only need the first, which is 4, minus the last, and the square root of 5 times the square root of 5 is just 5. 4 minus 5 is -1. So that means that my equation here is x squared minus the sum, which is 4, times x, plus the product, which is -1, which means that if I was to now take x squared minus 4x minus 1, set it equal to 0, and solve using the quadratic formula, without a doubt, I would get the answers 2 plus or minus radical 5. So this is just a time saver. There are other ways to do this, but this is certainly the most efficient. And the fact that everything in this chapter is open notes means that there's no reason why you can't write down this formula and then use it. In order to finish the problem, though, let's think about what that would look like. This is a cubic, which of course means that you need 3 answers. The fact that I already have 2 of them means that there's only 1 left. And because anything that is irrational or imaginary has to come in pairs, that means that the final root has to be a nice real number. Putting things with square roots and i's in the box for synthetic division is really not a great idea. It makes a big old mess. Now that I've taken these 2 roots and made a quadratic, synthetic division is no longer an option. So what do I need to do to find the third remaining root? I need to go ahead and bring back long division. So to finish this problem off, I'm going to have to do long division. So x squared minus 4x minus 1. And I'm going to divide that into the original polynomial. So that's x cubed minus x squared minus 13x minus 3. Remember, first into first, that's going to be x. So x times x squared is x cubed minus 4x squared minus 1x. Draw the line, change the signs. The cubes are out. 3x squared minus 12x minus 3. And just in case it wasn't obvious already, this has to go in evenly. Again, you're looking for all the roots. I've already found 2 of them, which means the final round of division has to yield the third factor and the third solution. So again, first into first, x squared times what is 3x squared? That's a 3. So fingers crossed, 3x squared minus 12x minus 3. Draw the line, change the signs, and would you look at that? I went ahead and got my 0. So again, there was 2 things that this problem asked you to do. It asked you to factor completely, and then it asked you to solve. So as far as the factor completely goes, the factors are x squared minus 4x minus 1 times x plus 3. And then the solutions are, if this is x plus 3, -3, and then 2 plus or minus radical 5. Those are the solutions that I already had, one of which was given to me, and the other I knew because it had to be the conjugate. If you're wondering, well, x squared minus 4x minus 1, is that factored completely? We're going to talk more about that in section 2.5. And again, that will all depend on whether I tell you to factor over the reals or the rationals or whatever it is I decide. So for now, just go ahead and factor over the reals. Here's homework number 16. So this is still section 2.3. Notice there's a couple special things here. So for 57 and 60, it asks you to factor and solve, and then it says check your graph with a graphing calculator. I'm going to ask you to try to graph it using end behavior and x and y intercepts, just like we did a few days ago. I gave you another quadratic regression, again, just to make sure that you could enter that data in the list, turn your stat plot on and off, and then go ahead and find a regression. So thanks very much, guys. That kind of wraps all the different division up for now. So thanks very much for tuning in, and we will catch you next time.